Hello, good morning everyone. Today we are going to see operating system unit 2 session 11. In the previous topic we have studied the concept first come first serve, and first come first serve scheduling algorithm is only based on non-preemptive scheduling. In today's topic we are going to study another scheduling algorithm, that is shortest job first scheduling algorithm. So by the name only you will understand the process which has shortest job, that process will be considered first. So the criteria which is considered in this algorithm is burst time. So the burst time is very important in this scheduling algorithm. So the process allocation will be on the burst time. Burst time means the total execution time of the process. So the process which has less execution time, that process will be given the CPU first. And it also has two modes, that is non-preemptive scheduling and preemptive scheduling. So first we will study non-preemptive. As I already told you about non-preemptive. In non-preemptive scheduling, once the CPU is allocated to any process, the CPU will be not taken away unless it finishes its full execution. Whereas preemptive scheduling is, once the CPU is allocated to the process, the CPU can be taken away at any given time, due to the situations like if the high priority process comes, if the time expires, or any other reason. In between there is an interruption in the preemptive scheduling. So first we will study about non-preemptive scheduling with the help of an example. But there are also some problem arises in the shortest job first scheduling algorithm. Now see, suppose if the shortest job processes keeps on coming, the less execution time processes keeps on coming, then the processes which has higher execution time, higher burst time, those processes keeps on waiting in the ready queue. So they faces the starvation. It may cause starvation if the shorter processes keeps coming. This problem can be solved using the concept of aging. But this problem can be solved using the concept of aging. In aging concept, the process which is waiting for a longer period of time in the ready queue, its waiting time will be considered, and its priority will be increased. That process which is waiting for a longer time, its priority will be increased, so that automatically when the priority increases of that process, automatically it will get executed. Aging takes into account the waiting time of the process in the ready queue and increases the priority of the process so that process can get executed. Scheduler must wait until job pool is completely empty before it can get more process for execution. Now let us understand this algorithm with help of an example. They are given here the process number and the burst time. They have not given here the arrival time. So if they don't give the arrival time, we have to consider that all processes have arrived at 0th unit. Now we need to consider here the burst time. The process which has less burst time, that process will be allocated first to the CPU. Now in this example, the less burst time is this, that is process P4. So the CPU will be allocated first to process P4. So you are going to start from 0th unit, all processes have arrived at 0th. So it is going to execute from 0 to 2 unit. Now next less burst time is process P1. So allocate the process for process P1. So how much unit it is going to take? 3 units. So 2 plus 3, it is 5. So you need to write here. So P1 is going to execute till unit 5. Then next less burst time is process P3. So allocate the process P3 to CPU now. And total how much units it will be executed? 4 units. So 5 plus 4 how much? 9. Next last process is unit 6. That is process P2 will be allocated to the CPU. and its unit time is 6. So 9 plus 6, it is 15. So this is the allocation of the processes based on the less burst time. Now we need to form the table. These are the process numbers which they are given, the burst time they are given. We need to find now completion time. So the completion time of process P1 is 5. Completion time of process P2 is 15. You can see here completion time of process P1 is 5. Completion time of process P2 is 15, and so on. We get here 9 and 2. Now we need to find out the turnaround time, that is completion time minus arrival time. So these values are completion time and these values are arrival time. So all processes have arrived at 0th unit, so all values will be 0 here. Now this is the turnaround values we'll get. Now you need to find out the waiting time. So turnaround time minus burst time. So these are the values of turnaround time which you will get here, values of turnaround time, and next this is burst time. So this column you are going to consider. So these are the values of waiting time. So you need to find out the averages. So average waiting time, average turnaround time is, you are going to consider these values divided by 4. 4 processes are there and 7.75 milliseconds will get the answer. Now consider these values for the average waiting time and divided by 4, you will get here 4 millisecond. Now this is your homework. They are not given here the arrival time, they are given process number and burst time. Consider the process first which has less burst time. Make the allocation of this process P4 first and remaining, so on. So let us consider another example. They are given the process number, arrival time and the burst time. So at the beginning we need to consider here the arrival time first. So check out at 0th unit which of the process has arrived here. None of the process has arrived at 0th unit. From 0 to 1 the CPU is going to remain idle. So we need to show that in this way. From 0 to 1 CPU is idle. Now check out at unit 1 which process has come. At unit 1 process P4 has come. So this is the first process which has arrived in the ready queue. So there are no any other processes still arrived in the ready queue. So at unit 1 first process has arrived in the ready queue. So allocate the process P4 to the CPU. And this is a non-preemptive scheduling. So once the CPU is allocated to process, it has to finish till its full execution. So it has to finish till unit 5, that is 1 plus 5, so it is 6. So process P4 will execute till unit 6. Now when process P4 is executing, check out if any of the processes have arrived in the ready queue. Now when process P4 is executing, at unit 2 process P5 has arrived. And at unit 3 process P2 has arrived. Okay, these are the already process which have arrived. Process P2 has arrived. At unit 4 process P3 has arrived here. So process P3 has arrived. At unit 5 process P6 has arrived here. And last at unit 6 process P1 has arrived here. So from these processes which have already now arrived in the ready queue when P4 was executing till unit 6, now from these processes the process which has less burst time, that process has to be now allocated. The process which has less burst time, that process will be selected now. Now among these P4 we have already completed, so we have to not consider this now. Now check out which process has less burst time. Process Yes, two processes we have here less bus time, process P1 and process P6. Now both bus times timing is same now. Now in this case we need to consider their arrival time. Check out from this two bus time, less bus time, which process has arrived first. Yes, process P6 has arrived first at unit 5 and then later process P1 has arrived at unit 6. So next allocation we are going to make, that is process P6. So P6 will be allocated here because it has less bus time and it has also arrived earlier than process P1, and it's going to execute till 1 unit from 6 to 7. Now process P6 we have completed. Now next process which has arrived is less time is process P1 now. Allocate the process for P1 which has less bus time, that is 7 to 8. Now next process we have already finished here from this list. We already finished process P1 also we have finished. Now these three processes are remaining. So this also we have finished. Okay. Now which we have next less bus time, that is process P5. So allocate the CPU for process P5. How much unit? 2 units it is going to take, that is 8 plus 2, 10. Then next bus time is less bus time is process P2. Process P2, and it is going to take 3 units, so 10 plus 3, 13 units. Then last process is 6, that is process P3. So allocate the process P3. So 13 plus 6, it is 19. So this is the allocation of the processes based on the less bus time. At the beginning the arrival time will be considered, and later on the bus time will be considered. So this is the table for this. Process number you need to, they are already given, arrival time they are given, bus time they are given. You need to find out the completion time of the processes, then find out completion time minus arrival time, and then turnaround time minus bus time, that is waiting time. Then find out the average of these values. Okay, turnaround time average and the average of waiting time, consider these values. Divided by 6 you need to do here in both the cases, and the value which you get is 7 and 4 millisecond. Now let us see another third example. They are given the process number, bus time and the arrival time. So at the beginning we need to consider the arrival time only. So check out at 0th unit which process has arrived here. At 0th unit process P4 has arrived. This is the first process which has arrived in the queue. No any other process has still arrived in the queue. So at the beginning allocate the process P4 to the CPU, and its execution time is 3 units. So it is going to start from 0 to 3. Now when process P4 is executing, check out the other processes which has arrived in the queue. So P4 is going to execute from 0 to 3. So at unit 1 process P3 has arrived in the queue, and at unit 2 process P1 has arrived, and at unit 3 none of the processes arrived. So when the P4 has finished its execution, P3 and P1 has arrived in the queue now. So from these two processes, which process has the less burst time? Process P1 has 6 and process P3 has 8. So process P1 has less burst time, so allocate the CPU for process P1. So its execution time is 6, so 3 plus 6, it is 9. Now when process P1 is executing, check out the processes which has arrived in the queue. Now already the process P3 is in the queue now, It is already in the queue. Now when the P1 is executing, check out the other processes which has arrived. At unit 3, none of the processes arrived. At unit 4, check out which processes arrived. Yes, at unit 4, process P5 has arrived, and at unit 5, process P2 has arrived, and at unit 6, yes, there is no unit 6, so all processes we have finished here. So these are the processes which has arrived in the queue when process P1 was executing. So among these three, which process has the less burst time? See, process P3 has 8 burst time and process P5 has 4 burst time and process P2 has 2 burst time. So less is process P2. So allocate the process to CPU, process P2 to CPU. So it is going to take 2 units. So 9 plus 2, it is 11. So process P2 we have completed. Now only 2 processes are remaining, process P3 and process P5. So process P3 has 8 burst time and process P5 has 4 burst time. So process P5 will be allocated first and its burst time is 4. So 11 plus 4, it is 15. And then last one, it is P3 and its burst time is 8. So 15 plus 8, it is 23. So this is the allocation of the processes. First we are going to consider the arrival time, and then later on we are going to compare the less burst time of the processes, and then we are going to make the allocation. So here we have completed non-preemptive SJF scheduling algorithm. In the next session we will see preemptive SJF scheduling algorithm. Thank you.